Okay, so this is going to be the part 2 where we're going to complete the square to go from standard to vertex. So here's a little explanation of why it's called completing the square. So basically what we want to do is change x squared plus bx into a perfect square trinomial. A perfect square trinomial is a trinomial that is the square of a binomial. So an example of a perfect square trinomial would be like x plus 2 squared is equal to x squared plus 4x plus 4. So that's a perfect square trinomial because it's a binomial squared. Another example would be something like x squared plus 8x plus 16. Okay, because that is x plus 4 all squared. So when a binomial squared gives us a trinomial, it's a perfect square trinomial. So here's an x squared plus 6x, so we're missing the third piece. So say this side is x, this side is x, then the area here is x squared. If this is a length of 6, then this area is 6x. So this entire thing here is x squared plus 6x. Okay? If we take this orange part, cut it in half, and put it in two places, then this is still x squared, because this is x and this is x. Now this is 3 and this is 3. So this is a 3x and a 3x, which is the same area as the x squared plus 6x. Now if we were to multiply the x plus 3 times the x plus 3, we would get all this area plus this little area here. So that's what we need to add, because then we'll have x plus 3 times x plus 3, and we'll get the whole perfect square trinomial. So the question is, what is that little green portion? What should that be? Well, if this is 3 and this is 3, then this is 3 by 3, so that's 9. So we've got the 3x, the x squared. This is an x plus 3. This is an x plus the 3. So x plus 3 times x plus 3 gives us x squared plus 6x plus 9. So what we want is x squared plus 6x plus 9, because that's equal to x plus 3 times x plus 3, or x plus 3 squared. So that gives us a visual representation of why we need to add 9. But where does that number come from? Well, it's this 6 divided by 2 squared, right? So we took the 6, we cut the 6x in 2 to get 3x and 3x. And then we notice that this is 3 and this is 3, so this is 9, or 3 squared. So this number that we add is always 6 divided by 2 squared, or b divided by 2 squared in general. So x squared plus 10x, we should already know that what we want to add is 10 divided by 2, which is 5 squared. So that's 25. But looking at the visual, here's x, this is 10, so this is 10x, and this is x squared. Now this is x squared. This is now 5x and 5x, because this is going to be 5 and 5. We cut it in half. Here's x, here's x. We want to do x plus 5 times x plus 5, but we're missing this little portion here. So what is that green portion? Well, if this is 5 and that's 5, then this should be 25. So again, that is x squared plus 10x plus 25. That's x plus 5 times x plus 5, geometrically, length times width. And that's x plus 5 squared. So to complete the square, you take the coefficient of x, divide by 2, square it, and add that. So coming over here, we want to put these in vertex form, which is why we're completing the square. Remember that vertex form is y equals a times x minus h squared plus k. So that right there, that's a binomial squared. So we need a perfect square trinomial. So that we can factor it to a binomial squared and put it in vertex form. And again, vertex form is super valuable, right? Because it gives us the vertex, the maximum height, or the minimum height, or the maximum profit, or the lowest depth. And it gives us the axis of symmetry and some other characteristics. So it's quite nice to have things in vertex form. So to complete the square, first of all, we're going to get rid of this pesky number and say Let's write it as y plus 11 equals x squared plus 6x. So this is the thing we want to complete the square on. So we're going to say divide 6 by 2 to get 3, then square it, add 9 to both sides. Now we've got y plus 20 is equal to x squared plus 6x plus 9. Got to remember to add it to both sides, otherwise it's not balanced. Now this is a perfect square trinomial because we divided that by 2, squared it, and added. So we know that makes a square. Y plus 20 equals x plus 3 squared, right? Going back to factoring, really what we're looking for is two numbers that multiply to 9 and add to 6. But that's 3 and 3, which is why it factors to x plus 3 times x plus 3, or x plus 3 squared. Now we can just subtract 20 and say y equals x plus 3 squared minus 20. We're now in vertex form. Over here, same thing. Subtract the 3 first. Now we need to complete the square, so divide 5 by 2, which is 5 halves, and square it. Now, a lot of times what we're tempted to do is try and get 2.5 squared or something like that, but I just encourage you to leave it as 5 halves squared, because we can actually do that in our heads. So 5 halves squared, just square the top and square the bottom. So that should be 25 fourths. And then x squared plus 5x plus 25 fourths, okay? Negative 3 is negative 12 fourths, getting a common denominator. This should factor to x plus 5 over 2 squared. That's how perfect square trinomials work. They always factor to a binomial squared, and this number is always b over 2, right? 5 over 2. Then we can write y equals, y plus, rather, 13 fourths, because 25 fourths minus 12 fourths is 13 fourths, equals x plus 5 halves squared. Add, or subtract 13 fourths, and y equals x plus 5 halves squared minus 13 fourths. And now we've put that in vertex form, and we can find the vertex. So I'm going to let you do these practice problems. But basically you're going to add 4, then complete the square, and see how that goes. Turning the page, so those were all nice because the coefficient was of a, or a was 1, but these have a leading coefficient that's not 1. And so in that case, we really need to we have to deal with that before we complete the square. So we follow the same process and we say y minus 12 is equal to negative 16x squared plus 32x. But because this has the negative 16, we only complete the square on x squared plus bx, not ax squared plus bx. So we need to get rid of that a while we complete the square, and then we'll bring it back. So we'll divide everything by negative 16, and that gives me y minus 12 over negative 16 is equal to x squared minus 2x, because 32 divided by negative 16 is negative 2. Now I'm going to complete the square normally. So I do negative 2 divided by 2 and square it. That's negative 1 all squared, which is 1. So add 1 here, add 1 here. I've got y minus 12 over negative 16 plus 1 is equal to, now I can factor this to x minus 1 squared, right? This is a perfect square trinomial, so it factors to that binomial squared. And now I just need to solve for y. So again, be careful here, because what has been done to y? Well, you subtracted 12, then you divided by negative 16, then you added 1. So we have to undo that in the reverse order. Subtract 1, multiply by negative 16, then add 12. So y minus 12 over negative 16 is equal to x minus 1 squared minus 1. I subtracted 1 from both sides. Now I'm going to multiply everything by negative 16 and get y minus 12 equals negative 16 times x minus 1 squared plus 16. Don't forget that the 16 has to be multiplied here, here, and here. Now I'll add 12. So y equals negative 16 times x minus 1 squared plus 28. Now I can see my vertex is at 128. This thing is quite steep and opens down because of the negative, so it has a maximum value of 28 and an axis of symmetry of x equals 1. So I know a lot about that function. Okay, let's try one more example and then you can do one. So we'll add the 7. Y plus 7 is equal to 2x squared plus 8x. I can't complete the square yet because of that pesky 2, so I'll divide everything by 2. Y plus 7 divided by 2 is equal to x squared plus 4x. Now I need to complete the square, so I'm going to divide 4 by 2, which is 2, and square it. That's 4. So I'll add 4 and add 4. Y plus 7 over 2 plus 4 equals x plus 2 squared. Again, this is a perfect square trinomial, so it's a binomial squared, and that number 2 comes from 4 divided by 2 squared. Of course, really, again, what I'm looking for is two numbers that multiply to 4 and add to 4, and that's 2 and 2. Now again, I need to solve for y by subtracting 4, multiplying by 2, and subtracting 7. So that's going to be y plus 7 over 2 equals x plus 2 squared minus 4. Subtracted 4. Now I'm going to multiply everything by 2. So 2 times that, 2 times this whole thing. Y plus 7 equals 2 times x plus 2 squared minus 8. Don't be tempted to distribute things here. The whole purpose of this is to not distribute, or rather to put it in vertex form. So we're not wanting to write it in standard form. Finally, subtract 7. Y equals 2 times x plus 2 squared minus 15. Now we know this thing opens up. It's twice as steep as a normal parabola. Axis of symmetry, x equals negative 2 because adding 2 moves to the left. Negative 15 has moved it down 15. So just to sort of think about all the things this tells us, it tells us the vertex is at negative 2, negative 15 down here. We already knew our y-intercept was negative 7, so maybe like right here. 0, negative 7. This is negative 15. There's our axis of symmetry at negative 2. It opens up, so it's going to look something like this. And we've got a minimum value. We know the range is negative 15 to infinity. We know the domain is all real numbers. We know the min is negative 15, so lots of stuff we can figure out from that. So I'll let you do this example. And I guess just as a summarization, we want to remember that to go from standard to factored, which is also sometimes called intercept because it gives us the x-intercepts. You factor. To go from standard to vertex, it's called vertex because it gives us the vertex. You complete the square. And to go from factored or vertex to standard, you distribute. So these are skills that we want to have when we're dealing with quadratics.